The question says it's a Boolean expression f equal to ab bar plus ab whole bar. So whenever there is a complement form that is in bar form, first of all try to put the De Morgan's theorem. Okay, De Morgan's theorem says ab bar is equal to a bar plus b bar. The same thing I have applied over here. It is a bar plus b bar plus a bar plus ab whole bar. Now try to find out if the same term is there or the number into the complemented form is there or the number plus complemented form is there. So we are seeing that it is a bar plus ab, and we can easily apply the formula a bar plus ab is equal to a bar plus b. So it is a bar plus b bar plus a bar plus b whole bar. Now we can rearrange it just like a bar plus a bar. Now what number plus the same number is equal to a number, means a plus a is equal to a, b plus b is equal to b, y plus y equal to y, z plus z equal to z. Similarly, a bar plus a bar equal to a bar. So a bar plus now b plus b bar, a number plus its complement form. As I have told you earlier also that a number plus its complement form is equal to 1. Just like a plus a bar equal to 1, c plus c bar equal to 1, y plus y bar equal to 1, z plus z bar equal to 1, and similarly b plus b bar or b bar plus b equal to 1. So it is a bar plus 1 whole bar. And we are very well known that something plus 1 is equal to 1. So this whole expression is turned out to be 1 bar. And one complemented form is equal to 0. So the whole expression is reduced to 0. Okay, here you are taking so many expressions, so many gates are there, but at last you are reducing it to the 0 value. Let's move to the next question. Question is f equal to ab plus a into b plus c plus b into b plus c. So there are so many brackets. As I have told you earlier also that whenever the brackets are there, try to open the brackets. And when you are opening the brackets, it is ab plus ac, then plus bb plus bc. Okay. Now, here I have seen that two things are there. One is the same number ab plus ab, and one thing is b into b. When you are just multiplying the same number, you are getting the same number. Means d into d is d, x into x is x, so b into b is b. So it is ab plus ac plus b plus bc. Why I have written ab? Because same two numbers, a plus a is equal to a. So I have written ab because ab plus ab equal to ab plus ac plus b plus bc. So it is ab plus ac plus b plus bc. Now we will see whether we can take some common term here out or not. Now b is, we can take b plus b bar c, we can take a b out. So it is ab plus ac plus b into 1 plus c. And we know that anything plus 1 equal to 1. So it is b into 1, that is b. So it becomes ab plus ac plus b. What you can do is, you can take common b from ab plus b. Take a b out, then it will become a plus 1. Although you can take a common over here also, you will get a into b plus c, but that will not reduce further. But if I take a b common out of ab plus b, I will get a plus 1, and 1 plus something is 1. So it is 1 into b, that is b plus ac. So this is the final answer. Just go through the question once again. Question is having so many brackets. Bracketed terms are there. ab plus a into b plus c plus b into b plus c. Just open all the brackets. So it is ab plus ac plus bb plus bc. Now b into b is b, so I have written b over here. ab plus ab is ab, so I have written ab here. So it is ab plus ac plus b plus bc. Now take the b out. So b is then 1 plus c. 1 plus something is 1, so it is b only. Here also ab plus ac plus b. Now take the ab plus b out. So b is a plus 1. Now 1 plus something is 1, so it is b plus ac. So this is the final answer. Here you will see you are taking many logic gates, but in the answer you are just having B plus AC, means only 3 terms are there: A, B, C, simple wire B, then A and C AND gate, then a OR gate. If the question is, just simplify it and reduce it and draw it using the logic gates. Now you can draw it using logic gates as, just take A, then take B, then take C. Now AC, you want AC, so A and C, you are just taking a AND gate. Okay, and B is there, so now plus sign is there, so you will take a OR gate. So this is the F. So you can easily see that a bigger expression can be reduced to a smaller simplified expressions just using the different laws. Okay, so it's all about the Boolean expressions, function minimizations, because you can easily see that there are so many expressions where we are using different kind of logic gates, but if you are applying the Boolean algebra, you are getting it in a minimized form. Otherwise, for example, you are taking A plus A bar, means I have to take a, then I have to take a complemented form, is a NOT gate, then I have to put a OR gate, then we can prove it is equal to 1. Otherwise, using Boolean algebra, I am just simply write 1. 1 means whatsoever the value 5 volt is there, we are just giving to the output side. So conclusion is, by this finishing this course, I'm in Boolean algebra lecture part, you are able to understand the various Boolean laws and theorems and how to apply this Boolean algebraic laws for the function minimization. Okay, the simply thing I am just showing you that, for example, B plus B bar. So if it is not a Boolean law exist, then we have to take a B, then we have to take a NOT gate of B, because it is a B plus B bar, it is now B bar. Now we have to take a OR gate here, then it is the output. Otherwise, whatsoever the value of 5 volt VDD is there, we can take to the output side. Here 2 gates are there. So if A plus A, if Boolean laws does not exist, you have to take A plus A again and again. But in case of Boolean law, it is easier to give the values A plus A equal to A. Means we can reduce the functions effectively. So it's all about the Boolean laws and theorems, and we can polish ourselves by taking the more practice problems. Okay, thank you so much.